Welcome back, students. In our previous video, we have discussed regarding galvanic cells and the construction and working also, and also the reactions which are involved in those galvanic cells. So in this video, we are going to talk about the cell notation. Cell notation, it is a shorthand notation of expressing certain chemical reactions which are involved in the galvanic cell. That means in the galvanic cells, we have seen the reaction, that is zinc will lose electrons to form Zn2 plus and copper will gain electrons to form Cu2 plus to Cu. So that's a long reaction. So we are just converting those big reactions into a shorthand notation. That means into a shortcut. So in order to do that, we are following these three steps. The first step is we need to keep the anode on the left and the cathode on the right side. So and the second thing is a single vertical line to differentiate between the metal and the electrolyte, and a double vertical line will represent the solvent which is involved in it. Let us take an example so that you will get the clear information regarding that. So first of all, don't get confused between Daniell cell and galvanic cell. See, galvanic cells, you know that it is also known as electrochemical cells. Those are the cells that are used to convert chemical energy to electrical energy. So in that, the example is Daniell cell. Daniell cell is an example for galvanic cell in which the anode which is taken as zinc and the cathode we will take it as copper. So Daniell cell is an example. What we have studied, that is a Daniell cell. That's an example of galvanic or an electrochemical cell. Do not get confused between these two, Daniell cell and galvanic cell. So now let us see the cell. Let us write the cell notation for the Daniell cell. You know that zinc we have taken it as anode in Daniell cell and copper we have taken it as cathode. So zinc is losing electron, so it is getting oxidized. That means zinc is the anode over there, and whereas copper is gaining electrons, so that means copper is getting reduced. So copper acts as cathode in the Daniell cell. So the first rule is we need to keep the anode on the left. So left side we need to have anode, and right side we need to have the cathode. So this is the cell notation for Daniell cell. This is the first one. A single vertical line to differentiate between metal and its electrolyte. That means zinc metal we have dipped in its own solution, that is zinc electrolyte, Zn2 plus ions. So the anode in this case is zinc electrode. So initially we have zinc as in the solid state, and later on a single vertical line we need to write to represent the difference between metal and the electrolyte. So later on zinc has lost 2 electrons to form Zn2 plus ion. So this one, and a double vertical line to represent the solvent. This is anode. Zinc has lost 2 electrons. Now, so this part is done. Now we need to go for this cathode on the right. So in Daniell cell, the cathode is the copper electrode. So copper initially it was Cu2 plus, which was the aqueous form, and single vertical line to differentiate between the metal and its electrolyte, and then it is converted to Cu solid. Clear? So this is the way of representing the cell notation. Whatever the cell may be, maybe a Daniell cell, or even if you take copper and silver. So in that case, copper will be anode and silver will be cathode. So this is dependent on the SRP values. So this is the way of writing the cell notation. Now let us discuss regarding cell potential. cell potential. Before this, we need to know about what do you mean by electrode and what do you mean by electrode potential. As told you in the previous video, what do you mean by electrode? Electrode is when a piece of a metal or when a metal rod is dipped in the solution of its own ions, we call it as electrode. That means zinc rod is dipped in Zn2 plus ionic solution. So that is a zinc electrode. So electrode is when a metal is dipped in the solution of its own ions, we will call it as electrode. Electrode potential means the potential difference between the metal rod and its ionic solution. So electrode is when a metal rod is dipped in the solution of its own ions, so we call it as an electrode. Whereas electrode potential is the potential difference between the metal rod and the rod which is dipped in the electrode. That particular ionic solution we will call it as electrode potential. This electrode potential is nothing but either the anodic potential or the cathodic potential. So you need to have and Daniel cell, a simple representation for your understanding. So this is a simple representation of an Daniel cell. So electrode means here zinc is dipped in Zn solution. That's an electrode. Electrode potential is the potential difference between this particular zinc metal and its ionic solution. That we call it as electrode potential. Be careful, electrode potential, that is we are talking about a single electrode, not a complete whole cell. Clear? Electrode potential of copper is the potential difference between the copper metal and its ionic solution. That is electrode potential. Now cell potential. Cell potential means it is the So finally, the cell potential is the potential difference between the two electrodes of the galvanic cell. That means the potential difference of this and the subtracting the potential difference of one more electrode. Finally, we get the cell potential. That is the total cell potential of the complete galvanic cell. So we have the formula for this one. So the cell potential is represented by E naught cell. E naught cell is given by E cathode minus E anode. So whereas in this case E cathode is the electrode potential of the cathode and E anode is the electrode potential of the anode. E naught cell is electrode potential of the whole cell. E cathode is electrode potential of the cathode. E anode is electrode potential of the anode of the cell. This is the formula in order to calculate the complete PSL, that is complete potential of the particular cell. So, in this case, how can we know this one? What is the, if you know the potential of cathode and potential of the anode, you can easily calculate E naught cell. But how can we know this one? So this electrode potential, we have a series in order to know this. So in order to calculate, let's calculate E naught cell for the Daniel cell. Okay. Daniel cell, we know that E cathode in Daniel cell is copper. The value is plus 0.34 volts, whereas E anode is zinc. E anode is zinc, that is the value of Zn is minus 0.76 volts. These are the standard values. So in order to calculate the E naught cell, E cathode minus E anode. In this, E cathode is copper, we have studied well. So E cathode is 0.34 volts, minus of E anode is that of zinc, minus 0.76 volts. So minus and minus, it becomes plus 0.76 volts. So the E cell value, that is the cell potential value of Daniel cell, is 1.1 volts. This is how we calculate the cell potential of other cells also, by knowing the values of electrode potential. These electrode potential values are given in a chart. We'll study about this one now. Yes, we are talking about electrochemical series now. Electrochemical series are the series of chemical elements which are all arranged in the order of their respective standard electrode potentials. See, you are familiar with this one, standard reduction potentials now. So both standard electrode potential, it is E. Standard electrode potential or standard reduction potential are both are same. Clear? So these electrochemical series are the series of chemical elements which are arranged in the form of their standard reduction potential or standard electrode potential. So in this we get the complete information regarding their reducing capacity and also the oxidizing capacity. So here we have silver, iron, copper, hydrogen, zinc, aluminum, magnesium and sodium and their respective standard reduction potential values. So according to our syllabus, that is relating to this chapter, we are much focusing for zinc, copper and also silver. And all of them are important, but we will be focusing more on these three. So we have already calculated the E naught cell value for the Daniel cell, which contains copper and zinc. So we have mentioned that the standard reduction potential value of zinc is minus 0.76. That means it is in the negative value, and whereas copper is plus 0.34, and we have assumed hydrogen as 0. This is actually not 0 based on this. The value, the assumed value of hydrogen, we have these standard reduction potential values, and regarding this we will study in the further video for the reference hydrogen electrode. So those, I will get the strength of oxidizing agent and the reducing agent through this series. So it means that copper, it is having plus 0.34. That means it is in the positive sign, whereas zinc, it is in the negative sign. That means copper has the more reducing capacity. We have said that from the Daniel cell, we have seen also copper will pull the electrons from zinc. The pulling capacity of copper is more when compared to that of zinc because of its standard electrode potential. It has more potential to pull. So as we go up the order, that means as the standard reduction potential values increases, they will become stronger oxidizing agent. Don't get confused, children. So copper is getting reduced. So it itself getting reduced means it is a good oxidizing agent. That means, so whereas zinc a good reducing agent. Clear? So don't get confused regarding oxidation. Oxidation reduction is different. Oxidizing agent and reducing agent are different. If a particular chemical element is getting oxidized, means it is a good reducing agent. Clear? When a particular element is getting reduced, it acts as a good oxidizing agent. Clear? So in this case, as you go up the order, the strength of the oxidizing agent will increases, and as you go down the order, the strength of the oxidizing agent will decrease. In the same case, opposite of this one, as you go down the order, weaker will be the reducing agent, and the stronger will be the reducing agent. So that means if you take this as an exemption 0, so these copper, iron, silver are good oxidizing agent, whereas this zinc, aluminum, magnesium and sodium they are good reducing agents. Clear? So this is the concept behind this electrochemical series. We can study regarding this electrochemical series in the further classes.